So hi everyone, it's Steven again. So in the last few YouTubes that I've done that have the physics bent, which I guess is all of them, I've been sort of basing it on the theory of how the quantum world and the normal regular world, I call it the thermodynamic world, but the Newtonian world, you could call it the timeline world that we live in, which is very different from the non-timelined quantum. That physics doesn't know. Physics has no conjecture, or science, I should say, has no conjecture about how those two things are actually joined. There's basically three choices of how those two might be joined, and the one that I've been going with is this super deterministic theory, which is all three of those have been known for maybe not 100 years, but 80 years. And the one that I've been running with has been the super deterministic. And that's where there's something going on in the quantum. There's information in the quantum world that we don't see. From our point of view on the outside, the quantum looks completely probabilistic, but that there's something more there that's coming through into our world. And so that translation from quantum to the timelined Newtonian thermodynamic world that we live in is loaded with the information that causes our world to proceed in the way that it does. So how do you go from probabilistic to timeline? And the way this conjecture is saying is that superdeterminism means that there's more information that's flowing into our world from the quantum world that contains the instructions necessary for our world to proceed in the way that it does, so that we aren't also in a highly probabilistic world. So that's one theory, but it's the least popular theory, and the reason is it sounds like you're invoking God, right? It sounds like you're invoking a directing. That the quantum world is somehow directing our world, and we don't know how that is, and so we say, well, why would we do that? And the reason we would do it is because the other two alternatives are these, that one is that, okay, so there's something missing, and if we add some variables of our own choosing with their own properties of our choosing to the maths of the quantum world. If we add our own maths, then one leads to the other. So yeah, so it's like, well, our world works this way, and if we want to build things, we have to go according to the way our world works. And we know that there's also quantum dynamical properties, and they don't quite fit. So we'll just say that when the quantum world translates into our world, that we're just going to throw these variables in to make it work. Make the thing work. The machine appears to have two gears and nothing else, and so we add some oil, or something like that. We add a weight that, and then you just don't worry about it. And that's the way that physics and science and engineering has gone for the last 80, 100 years. Is, well, it's interesting. We have a quantum world, and it's interesting that must be, but it's also true that we need to get things done, and so. If we add these properties, then everything will work, and we're just not going to worry about how it is that just this ad hoc addition of properties, if as long as we aren't knowing what's going on, we're just going to add the things that make it work, and so that's that's practical, that's. We wouldn't have the science producing the things that through engineering, the things that it has, if it weren't for that. So that's all well and good. The other third possibility is one that you hear about every now and then. This many worlds thing. I think a lot of science fiction is built on this many worlds aspect. That the quantum world is probabilistic, and that it's not true that it somehow translates into our world, It's that our world is one of the probabilities, is only one of the probabilities in that quantum world. So rather than the quantum world's array of possibility, array of probability collapsing, right? You hear wave function collapsing into the world that we know. That the quantum world doesn't, and that we are simply on one of the probability curves. And the issue with that is that these quantum choices happen all the time. And so every time there's a quantum choice, there's an array of possibilities, and each one of those possibilities exists. So it adds up, right? I mean, you get a lot of universes, like a lot, and so there's in that idea, so it's the science fiction says, well, we have these other universes, and we populate it with other interesting features, and then you have interactions between those features, and that's a lot of fun. I agree, it's a lot of fun. But the reality of the scientific conjecture of many worlds is that many is like many, like more than we have a number for, I suppose. And it gets down to the number of worlds ends up being in something that's called de Sitter space, and de Sitter, Desitter, and de Sitter space is simply the number of degrees of freedom that can exist in the quantum universe, and it's a lot, right? It's because it's such a gigantically large number that these worlds can exist each in their own degree of freedom, and de Sitter space is large enough to accommodate every time quantum choice is made, you end up with a range of possibilities, and all those exists. And you can just, and these quantum choices happen all the time. So there's no collapse, but there's many, 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 many worlds, right? So I prefer the superdeterministic, which is I think the most straightforward. There's something we don't see in the beginning. I prefer that to we just throw in something to make it work. Although I'm glad that engineers do that. Let's be clear, right? So, but then it's also fun to think about the many worlds, and the many worlds is enticing because you don't have to add anything. You don't, the quantum world is probabilistic, and it proceeds according to the Schrodinger equation, and the Schrodinger equation is extremely accurate. I think it's the most accurate theory that we have of anything. So if you go along with the idea that de Sitter space is large enough to accommodate every quantum universe that exists through every quantum choice associated with each probability of each of those individual choices, then if you go along with that, then you don't have to add stuff to make it work, and you don't have to conjecture that there was something that you didn't see in the quantum that then projects into our world and not other worlds. So I'm going somewhere with this, and I'm going to stop here. I'm going to stop here with this one. But what got me started on this, I just want to give a shout out. What got me started on this is last night I had a conversation with Shari in the TLC. So this little corner, there's Shari is in there, and we had a talk last night. And though we didn't talk about anything that I'm talking about now, what we were talking about got me thinking about this, and it got me thinking about how this could be related to a Christian theology. So in the next few YouTubes, I'll be placing this many worlds concepts into an Orthodox Christian theology in a way that I hadn't thought of before in any way, but thanks to that conversation, and thanks to the things that I've been reading, all of a sudden this is like, well, wait a minute, if superdeterminism isn't true and it's many worlds is true, I'm not left high and dry without a theology to accommodate it, that I'll have now another theology that'll accommodate the many worlds. So that's it for today. Thanks.